Welcome back, my wonderful algebra students. This is lesson 5.5, performing function operations. I think here at the beginning, you're going to find this is pretty easy. So here on this page, we're just looking at all of the different function operations we have. There's addition, subtraction, multiplication, and division of functions. I don't think you're going to have too much trouble here. If you just look here in the middle column, we see the different notations that we can have. So whether we write it as a parenthesis f plus g, close parenthesis of x, we write it as f of x plus g of x. They mean the exact same thing. So I'm not too worried about the notation here. This is just what this middle column is. It's just telling us about the different notations that we can have. In the far right column over here, we have the two examples for each one of these, where I've defined f of x as being 2x squared and g of x as to be 3x. And then I just go through and show you exactly how to do it. It's not anything crazy here going on. You'll see that when I add the two functions, it's like combining like terms, or subtracting, keeping them separate. If I'm multiplying, of course, I'm going to multiply the numbers by the numbers and the variables times the variables. So down here, I end up with 6x to the third. And then the division, you could keep this. We did 2x squared divided by 3x. We simplified that. I ended up with 2x over 3, or 2/3 x. They're the same thing. It's really up to you. This last statement down here is kind of important. The domains of all four of these functions are going to be whatever f and g have in common. If you want to think about that as like a Venn diagram, right? Oh, I haven't seen these in English class. The domains of all of these functions are going to be whatever is the overlap of those two areas. What is in f and also in g. Typically, we're not going to have to worry too much about this, at least here at the beginning. The only thing that you do have to remember is that the quotient, the denominator, can't equal 0, so we have to exclude those values. That may mean an additional step. Let's take a look at some example problems. So evaluate f plus g, f minus g, f times g, and f divided by g. State the domain of each and then evaluate each for the given x. So in A, we have f of x is equal to x squared minus 4x, and g of x is equal to 2x minus 7. And then later we'll evaluate them for x equals -4. We'll do that each individual separate. So this is like doing really like 8 problems at once. But I think you can do it. So why don't you try right now? You can pause the video. I'm going to go do these in order, f plus g and then f minus g. So if you want to take and pause the video right now and try these out on your own, I think you can do it. I think you'll be surprised at how successful you'll be. So give it some thought, pause the video, and then I'll show you the solution. Okay, so the first thing I'm going to do is I'm going to do f plus g. F plus g of x. Well, let's hear. That's the same as taking f of x plus g of x. And let's hear. My f of x function is x squared minus 4x. And my g of x function, which I'm going to add, is 2x minus 7. It's actually not a bad idea if you use parentheses here, although I think we'll find out with addition it doesn't make a bit of difference with that. So what I'm going to do is I'm just going to drop the parentheses and combine like terms. So what does that give me? Well, there's no x squareds in the other time, so it's just x squared. I have this -4x plus 2x, which will give me minus 2x. And then I have this minus 7. That's all there is to it. X squared minus 2x minus 7 is f plus g. And now we're going to plug in the number 4. So we can do this one of two ways. We can either add the two functions and plug the 4 down here into this equation if we wanted to, or what I like to do is I can do f of -4 plus g of -4 and get the same thing. So let's see here. That would be -4 squared minus 4 times -4 plus 2 times -4 minus 7. Okay, so let's hear. It gives me 16 plus 16 minus 8 minus 7. Let's hear. That's 32 minus 8. I get 17 as my final answer. Let's talk about the domain of f plus g. Well, let's hear. F plus g. Well, the domain of f of x is all real numbers, and the domain of g of x is all real numbers. Remember what I'm looking at. I'm looking for numbers that are, am I taking the square root of a negative value? I'm not in this problem. I'm not in f of x. I'm not in g of x. Am I dividing by 0? I'm not doing any of that in either of these. So the domain of f of x and the domain of g of x is both all real numbers, which means the domain of f plus g of x is also all real numbers. Let's take a look at the subtraction problem now. So again, same idea. F minus g. F minus g is the same as f of x minus g of x. Same idea. So f of x is x squared minus 4x. We'll do minus g of x, which is 2x minus 7. Now, in this problem, we have to be careful. The negative sign here, we have to make sure we distribute the negative through to both of these. So this problem actually turns out to be, let's see here, x squared minus 4x, nothing happens there. But then it's minus 2x, and here's the big thing, plus 7. That's going to be different, and you got to make sure you distribute through that negative sign, or you'll never get there. So let's see here. I combine my like terms. I get x squared minus 6x plus 7. All right, so now we're going to evaluate this for negative 4. So I'll do f minus g of negative 4. And what does that mean? That means I take this function down here, and I plug in negative 4. So that's a negative 4 squared minus 6 times negative 4 plus 7. And when I do that math, let's see here, negative 4 squared is 16. And I got plus 24 plus 7. Get my calculator out. I come up with the answer of 47. You'll see that I did this problem different. I did the subtraction and then plugged my negative 4 into that answer. Really, like I said, it doesn't matter which way you decide to do it. So again, let's look at the domain of f minus g. Again, remember, the domain of f of x is all real numbers. The domain of g of x is all real numbers. So the domain of f minus g is also all real numbers. There's nothing exciting going on here. Let's take a look at multiplication. So f times g, that's the same as f of x times g of x, which is, again, x squared minus 4x times 2x minus 7. Okay, I got a FOIL here. So it's a binomial times a binomial, so I'm going to FOIL. So let's see here, that'll give me 2x to the third. When I do these two, and then I do the outsides, I have minus 7x squared. I do these insides, minus 8x squared, and of course, my lasts plus 28x. All right, so now I have to just combine my like terms. Let's see here, I get 2x to the third minus, these are my like terms, 15x squared plus 28x. All right, now let's evaluate f times g of negative 4. What that means is I'm going to take this equation down here, just plug in the negative 4. So I got 2 times negative 4 to the third power minus 15, negative 4 squared plus 28 times negative 4. Trust me, plug that in my calculator. If I've done it right, forget the parentheses, I get negative 480. On to what about the domain of f times g? Well, again, all real numbers for f of x. The domain of g of x is all real numbers. So the domain of f times g, all real numbers. So for division, f divided by g is equal to f of x divided by g of x. That's a no-brainer. We're going to just plug it in. Let's see here, that's x squared minus 4x over 2x minus 7. That's it. No brain busters here. So let's see here. I'm just going, I can't simplify that. It's not like I can factor off the top and make it simplify with anything. So now we'll just go ahead and we're going to evaluate it at negative 4. So f divided by g of negative 4 is equal to, let's see here, that's negative 4 squared minus 4 times negative 4 over 2 times negative 4 minus 7. So here on the top, that's 16 plus 16, which is 32. And on the denominator, what that's negative 12 minus negative 8, sorry. Negative 8 minus 7, which is negative 15. That's my final answer. Negative 32/15. Nice. All right, let's talk about the domain of f divided by g. Again, domain of all f of x is all real numbers. The domain of g of x is all real numbers. So the domain of f divided by g is not all real numbers. Oh no, what happened here? Oh, okay. In this particular problem, we have to be worried about when this denominator of 2x minus 7 is equal to 0. Well, when does that happen? That happens when x is equal to 7 over 2. Don't believe me? Go back, check it out, do the math, set 2x minus 7 equal to 0, solve it out. we know that x cannot equal 7 over 2. So it's not all real numbers, it's just everything but 7 over 2. All right, if you didn't pause the video last time, pause it now, try this problem. Same idea, find f plus g, f minus g, f times g, and f divided by g, state the domain, and then evaluate this for the given x value. So we have f of x equals 2 square roots of x, g of x is equal to 3x to the 2/3 power, and then we're going to evaluate that at x equals 64. Go ahead, pause the video, see if you can do it. Good luck. All right, first things first, let's do f plus g. That's going to be 2 square roots of x plus 3x to the 2/3 power. Yep, I'm done here. Can't do anything else with this. That's it. They're not like terms. I can't combine them. All right, let's figure out what f plus g of 64 is going to be. That's 2 square roots of 64 plus 3, 64 to the 2/3 power. Let's see here, 2 square root of 64 is 8 plus 3. Let's see here, 64 to the 2/3 power is the same as the third root of 64, which is 4, squared, which is 16. Okay, my final answer here is then 64. Let's talk about the domain. Ooh, this one's different, right? The domain of f of x. Oh, I can't take the square root of negative numbers. So it's x is greater than or equal to 0. That's what the domain of f of x is. The domain of g of x. Okay, well, remember, this is like the third root, so it really doesn't matter. This domain of g of x is all real numbers. So what do they have in common? What's the overlap? Well, since the overlap is x greater than or equal to 1, or sorry, 0, that means that the domain of f plus g is x greater than or equal to 0. Subtraction, f minus g. Let's see here. That's 2 square roots of x minus 3x to the 2/3 power. Yeah, nothing exciting going on here either. Very little to do. That's actually the answer. So let's evaluate that and plug in 64. So that gives me 2 square roots of 64 minus 3, 64 to the 2/3 power. I feel like I just did this problem, but it's subtraction. That's 2 times 8 minus 3 times 16, which will give me my final answer of negative 32 when I do the math. All right, same idea here. Domain's actually the same. The overlap of the two, x greater than or equal to 0. Maybe multiplication will be a little more exciting. F times g, what's that? That's 2 square roots of x times 3x to the 2/3 power. Oh, okay, so this I actually should do something. I need to remember that x is actually, the square root of x is actually x to the 1/2 power. So that's times 3x to the 2/3 power. And you'll see that the base numbers are the same. That means that I can do more math. Think of your last test. So I'll do 2 times 3 and get 6. I'll get x to the 1/2 times x to the 2/3. That means I add up those exponents when I do that. And I get, let's see here, 1/2 plus 2/3. That's 7 over 6. That's 7/6. Okay, not bad. We'll now do f times g of 64. So we'll plug in 64. 6 times 64 to the 7/6 power. Now, I didn't bother doing that in my head. I got my calculator out. I did 64 to the 7/6 power, and I got 128. So it's really 6 times 128, which is 768. Thank goodness for calculators. What about the domain? What is the domain of f times g? Still the overlap here, folks. Same as before. X greater than or equal to 0. All right, now what? Let's see here. Let's do the division. F divided by g. That's 2 square roots of x over 3x to the 2/3 power. Same idea as the last problem. I should rewrite this as a rational exponent. So 2x to the 1/2 power over 3x to the 2/3 power. And again, I can simplify my radical here and subtract the exponents. So I will have 2/3, that's the fraction there. And then if I do 1/2 minus 3/2, or 2/3, I mean, 1/2 minus 2/3, I get, let's see here, that's negative 1/6. I'm actually going to be okay with that answer. I'm going to leave it like that. I mean, I guess I could go ahead and rationalize the denominator if I wanted to think of it as like 2 times 3 sixth roots of x. And then if I rationalized it, I'd get 2 6 of x to the 5th over x, and or for 3x, but that seems like a big pain. So let's just keep it here. We'll keep it here for now. You're welcome. We'll plug in our value now, though. We'll do f divided by g of 64. And when I do that, that gives me 2/3 times 64 to the negative 1/6 power. Plug that in my calculator, and I'd get, let's see, that's 2/3. 64 to the negative 1/6 power is 1/2, which gives me my final answer of 1/3. Let's talk about the domain. Let's see, what's the domain of this? Well, again, this is where we have to be really careful because it's not as easy as it was in the other ones where we just wrote x greater than or equal to 0, right? Because in this particular case, we have to be very concerned about the denominator. And I know you may not see it here, but we can't have g of x being equal to 0. So what value makes 3x to the 2/3 equal to 0? Well, 0 itself. So that means that this whole part right here, the inequality part, the equal to part of the inequality has to go away. So that means my final answer, after I erase that, is x greater than 0. There is one more operation that you can do on functions called the composition of functions. And what composition of functions is when we take one function and plug it into the other. So the notation looks a little bit like this. It's f circle g of x. So f circle, that is a little circle that's there. It's not the letter O, but that's a little tiny circle. So f of g of x, that's what this means. And that's the same as writing it like this. It's f and then parenthesis g of x on the inside. And what we're going to do is when we see this, we're going to take the function g and we're going to plug it into the function f, as you'll see in the next example problem. Let me show you. So directions. Evaluate f of g of x and g of f of x given f of x is equal to 2x minus 3 and g of x is equal to x squared minus 4x. So we're going to do the first one first. We're going to do f of g of x. Now, what we're going to do, we're going to take g of x and we're going to say f of, right? And in that, we're going to put in g of x. G of x is equal to x squared minus 4. So we're going to plug that in. X squared minus 4x. All right, so what do we do? Now, every time we see an x in function f, so right here, we're going to replace it with x squared minus 4x. So what does that give me? So let's see, that means I have 2, and then that's where x would go, minus 3. And then in that spot right there, we're going to put in x squared minus 4x. So we replace the x in 2x minus 3 with x squared minus 4x. That gives us 2 times the quantity of x squared minus 4x minus 3. And now we just go to simplifying. So let's see here. Let's see, we do distribute the 2. We get 2x squared minus 8x minus 3. All right, let's try that again. Let's do g of f of x, the second half to that part. So again, we're going to take function g, and we're going to replace and put f of x into function g, so 2x minus 3. So we're going to replace every x in function g with 2x minus 3. So what's that mean? That means this x squared and this x, both of them will turn into x minus 3's. So let's see here. So we have 2x minus 3 for that first x squared minus 4 times 2x minus 3. All right, then all we have to do is multiply this out or simplify this expression. So 2x minus 3, let's see here, 2x minus 3 times 2x minus 3. I will just go ahead and multiply that out for us. I get 4x squared minus 12x plus 9. Distribute through the negative 4. That gives me negative 8x plus 12. Then I'll combine my like terms. That gives me 4x squared minus 20x plus 21. All right, 2 answers. Let's look at a variation on this problem. So here we're going to evaluate f of g of 3. Oh, okay, so you'll see that it's not an x, it's now a 3. So this, I think, is actually easier than the last problem. What we're going to do is we're going to start on the inside, and we're going to evaluate what's on the inside. So that means g of 3. We're going to evaluate g of 3. And if you remember what that means we're going to take the function g and we're going to replace every x with the number 3. So that's here. That means we have 3 squared minus 4 times 3. And then I just simplify things. So 3 squared is 9 minus 12 gives me negative 3. All right, that's g of 3. So we know that g of 3 is equal to negative 3. So what does that mean? That means now we're going to replace the g of 3 with this negative 3, which means we're going to evaluate f of negative 3 now. So now, what's that mean? That means we replace the x in function f with the number 3. So that's 2 times negative 3 minus 3, which gives me negative 6 minus 3, which gives me the final answer of negative 9. Like I said, I think that is a whole lot easier than doing it with functions themselves when we're just working with numbers. All right, so here's a problem I'd like you to try. Evaluate f of g of x, g of f of x, and f of g of 7, given f of x is equal to x squared minus x plus 1, and g of x is equal to the square root of x plus 2. Why don't you pause the video right now, take a look, see if you can do this, and then we'll check our answers here in a second. Good luck. All right, so first thing we're going to do is we're going to evaluate f of g of x. Okay, so we start with function g. And let's hear f of g of x is equal to the square root of x plus 2. And we're going to take that square root of x plus 2 and we're going to plug it into function f. So let's see here. Let's see here. That means we have the square root of x plus 2 squared minus the square root of x plus 2 plus 1. That's it. That's all there is to it. So I do want to do some math though. So like, for example, I know this squared and this square root cancel each other out. So that'll give me just x plus 2. Can't do anything with this minus the square root of x plus 2. But I can, with this plus 1, combine my like terms. So my final answer is going to be x plus 3 minus the square root of x plus 2. That's pretty much all there is to f of g of x. Let's do the next one. Let's do g of f of x. So what's that mean? That means I take g and I'm going to replace the f of x with x squared minus x plus 1. All right, that means that when I look at function g, which is the square root of, it's not x anymore, now it's x squared minus x plus 1 plus 2, all of that underneath the radical. Okay, so now what can I do here? Well, not much. Looks like I could just combine my like terms here, the plus 1 and the plus 2, and get x squared minus x plus 3 underneath the radical. Not much else I can do. Looks like I'm done this problem. Finally, f of g of 7. Again, like I said, start with g of 7. What's g of 7? Well, let's see here. That's the square root of 7 plus 2, which is the square root of 9, which is 3. So g of 7 is equal to 3. Well, now we're going to do f of 3. Okay, so let's see here. What is that? That means it's, it's 3 squared minus 3 plus 1. All right, simplify it down. It's 9 minus 3 plus 1. 9 minus 3 is 6 plus 1 gives me 7. So f of g of 7 is equal to 7. Cool. All right. Folks, please pay attention with these. The composition of functions can get a little tricky, but if you keep things straight, I think the color coding helps tremendously. You should be all right with this. So good luck with your assignment now.